Hi, this is Jai Kumar. My student ID is 101236674, and this is my submission for assignment 1 for Com 3132 Applied Machine Learning course. So we were supposed to get the uh, fashion MNIST data from the Keras datasets. So we import that here, the fashion MNIST, and then we segregate the data into train images, train labels, and test images and test labels from the fashion MNIST data. Now for the first part, we were supposed to find out dimensions of these train images, train labels, test images and test labels. So the dimensions are as follows. For images, it's 60,000 for the train images, and then it's 28 by 28 pixels. So here are the information about the pixels. And for the labels, just 60,000 labels. And for the test images, 10,000 and 28 by 28 pictures. For the second part, we were supposed to find the length of train labels and test labels. So as we did that, and the length for both of those for the train labels was 60,000, test labels were 10,000. Now for number 3, we were asked to show a few test and train labels. So we picked a random number for train labels 10th, 100th index and 1000th index, and the answers were 081, and for the test label it was 999999. It was these answers. So now for number 4, we had to show the digital content of image at index 5 training dataset. So this is the digital content of the image, and for plotting the image, we use the matplotlib.pyplot library and used to show it through the binary operations. For number 6, we were asked to do the same thing, but for the training dataset and at index 5, the label for index 5, and the label at index 5 was number 2, which is pull over in the category. So I think, yeah, it's pretty accurate. For number 7, we had to show digital content of index 500 in testing dataset instead of the training one. This is the image and this is the result. So this result is also for a pullover. Seems like the same thing. So now we are asked to import models and layers from the Keras library. So for models, we just use from Keras import models, but for the layers, we use the TensorFlow library and then Keras and import layers. So we were asked to define a sequential model and call it my network. So I did that here and had to reshape the images from 28 by 28 into one column with 784 neurons. So this is the book method that I got, but I was unable to understand the part of it in the video, so I wasn't able to do that. For number 13, we asked to normalize this image by dividing the image by 255. So first of all, we convert it to the float type and then we divide by 255, so we get an answer. So first of all, we add a layer, a hidden layer with 512 neurons, and activation method is ReLU. For the input shape is 784 because as we have already flattened the train and test images. Next, another hidden middle layer, my network.add layers. This is 128 neurons and activation is ReLU. And for the last one, the final layer, we added a dense layer of 10 neurons and activation softmax. I think we use the softmax function because of its accuracy with the probability and stuff. Now we were asked to use two different settings for the compiler, them separately. So for the first one, you use Atom Optimizer, sparse categorical cross entropy as loss, and metrics for that was accuracy. So when we run that, I got this first compiler one, and as we can see, the loss is 0.4525 and accuracy is 0.8379. Now then I used the other model. For that I had to import the two categorical library from TensorFlow, Keras and Utils. The optimizer is RMS prop, loss is categorical cross entropy, metrics are accuracy. and to fit the data into this category, I had to convert it into categoricals. So I did that, and I use the fit pattern for the second compiler, and for the second compiler, accuracy is a bit more and loss is less. So I think this was a better method. So for the second compiler, the loss is 0.2536 and accuracy is 0.9044, which are better than the first compiler. So now that was the 18th part. For 19th, we were asked about what difference we felt in the fashion MNIST and MNIST data and why we feel that. I think it's because with the MNIST database, it was more simple, handwritten numbers, which were, I think, easier to understand by the machine than something as complex as the photos of garments. So I think that played a huge role in dropping down the accuracy for that. For the last one, we are to find the loss over estimated and accuracy. So the accuracy calculated was 0.8622, so it's around all that, and the loss was 0.3838, which again is lesser than the MNIST model because of the complexity of the images. And that's it for my assignment. Thank you for watching. Have a wonderful day.